Section 5.6, Atmospheric Pressure. So remember that fluids exert pressure, and that even though you may not realize it, we're sitting at what is the bottom of an ocean of air. There's a whole bunch of atmosphere up above you, and that atmosphere pushes down on you. All of the air in the atmosphere exerts a pressure on the surface, and we call that pressure atmospheric pressure. This atmospheric pressure is caused by the weight of the air above you. It's much like being underwater. Now, you don't feel this pressure on you because you have an internal pressure that is equal to the external pressure that you experience. However, this pressure is really, really great. Now, at sea level, a cubic meter of air, so a volume of air that is a meter on all three sides, a cube, at 20 degrees Celsius has a mass of about 1.2 kilograms. So that means the air in the room probably has a mass of about 5 kilograms, depending on what size room you're in. Now, you don't notice the weight of all that air around you because everybody's submerged under all of that air. We all experience it the same way. Nobody's experiencing it any differently. However, if you start to go up from the surface of the earth towards the air, you soon see that the density of the air decreases with altitude because gravity holds most of those air molecules close to the surface. So when you get high up in the air, you can't breathe the air that is up there. And so this is why we have to pressurize airplanes when we fly them. This is why if airplanes depressurize, they have to drop down to a certain altitude. So the average atmospheric pressure at sea level we refer to as 1 atmosphere, but we also use units that are known as pascals, which is newtons per meter squared. So 1 atmosphere is equal to 101,000 newtons per meter squared. That is not a small amount of force. It's a pretty great pressure. And you can see how great this pressure is if you watch the other videos at the end of this lecture. Now, in order to measure atmospheric pressure, we use what's known as a barometer. Atmospheric pressure is important because it allows us to predict the weather. If you look at weather reports, they're always talking about high pressure systems and low pressure systems. In general, high pressure systems refer to good weather. Low pressure systems refer to bad weather. When you have something like a hurricane, you'll notice that the pressure will drop significantly, and we use barometers to measure this atmospheric pressure. Now, mercury is generally used in barometers because it has such a high density that you can make a really small barometer, one that's just about 76 centimeters tall, so about half a meter. Barometers work by balancing the air pressure inside the barometer with the air pressure outside the barometer. The air on the outside pushes down on the liquid mercury, and that liquid mercury is pushed up into this tube, and by measuring the distance, you can determine the pressure. Because mercury is so dense, it allows for barometers to be made that are smaller than a meter. If you tried to make a barometer out of water, it would have to be 13.6 meters tall. So that's about 2 stories, if not more than that.